My name is Jaakko Härkönen, and the title of our project proposal is Detector for Nuclear Safety, Decommissioning and Diagnostic Applications. We are a team of 3 senior scientists. All of us, we have several decades of experience in this field in different laboratories and universities all around the world. So in addition to me, our team is made of Professor Pani Luukka. She's a doctor in technology and specialized in semiconductor and radiation detection technologies. She's currently holding a full professor position at the Lappeenranta University of Technology. Then the third member of our team is Doctor in Technology Eija Tuominen. She's currently Director of the Detector Laboratory of University of Helsinki. So, for the need of our activities that we have been carried on for a couple of decades is nuclear safety. And what nuclear safety stands for? It's basically nuclear safety covers all operations, daily operations, maintenance, decommissioning, at all different kind of nuclear installations. Nuclear installations can be, for instance, nuclear power plants, or they could be research settings or big institutes with accelerators, like for instance CERN Large Hadron Collider. So in short, what is the nuclear radiation detection? So if we want to be safe from dangerous nuclear radiation, we have to measure it, right? Okay, and it requires a measurement and detection of very broad spectrum of the photon rays, like X-ray, Röntgen, gamma rays, and different particles that deliver the radioactive radiation. To shortly describe this, we have selected 3 illustrative examples. The first one is rather a recent one. It wasn't not a big time disaster, but it was costly for Teollisuuden. It happened 10th of December 2020. Then the second example is a very well known and famous Sellafield site in the north of England. And this problem has been ongoing since many decades, almost since 1960s and so on. And the payload for the British taxpayers is huge. The third example we have picked up happened about 9 years ago, and this is very annoying and unfortunate happening at the Fukushima nuclear power plant, and yet nobody knows what is the cleaning up end cost of this whole thing. So this is in nutshell for what the nuclear safety radiation detection is needed. So let's switch to our approach and the problem in this particular field. The problematic stands for, in many cases, how to detect unknown radiation contamination or incoming radiation flux in difficult accessible places. It's obvious for everyone of us that we cannot, physically access to the Fukushima or some very highly contaminated areas. And what is the current commercially existing offerings or settings? They are typically very old technologies coming from decades before. They might be very heavy, large, clumsy, and most of all, these solutions that are offered for the international community, they are extremely expensive, to be honest. So what we have been thinking for several years already is something that could be a relatively small size, cost effective, and simultaneously cutting edge, accurate method to detection of the incoming radiation. And when talking about accessing difficult areas, it would be quite important that it could be accessed remotely controlled, not by the human beings, because nobody of us want to access in these places. So that's what we have been thinking about quite a lot. Okay, our approach. I would like to start how is a radiation detector made, just shortly. So basically, the making of a radiation semiconductor detector, it's a process flow of 3 different processes. First, start with the design with the office desktop computer. That is followed by the second step, physical processing in dedicated clean room facilities. And luckily in Finland we have in Otaniemi this Aalto University and VTT jointly maintained and owned Micronova and Otaniemi facility. And in fact, at the Micronova, we and our group, we have been operating for since more than 20 years, or since Micronova was established. Then the third part of the making of process is, of course, performance qualifications, what we have done. And this is illustrated in just a few scientific pictures. And I don't at this moment want to go to details of this. So furthermore of our approach, we call it a detector which is made of A, B and C sensors. And this ABC approach, it is because it is technologically and physically impossible to implement all measurement and detection properties over this very broad spectrum in one and only single detector. That's why we want to implement ABC, or it could be, depending on the customer needs and specific applications, it could be scalable up to the ABCD or ABCDE detectors. So that's what we have been thinking and planning. And these sensors A, B and C, they are already existing. They have been characterized, measured. We know very well, we definitely know that they are world-class cutting-edge technology that no existing commercial vendor can provide to any customer at this point. In this project proposal framework, we are prepared to collaborate with the different Finnish expertise companies, research institutions and the stakeholders. Just in this slide I list few of them, but in addition, the big magic in our expertise is based on the so-called atomic layer deposition technology, ALD, which is a kind of a at least in Finland, very well known processing technology for the functional thin films. And as far as we know, we are the one and only group globally that has ever implemented ALD technologies to the radiation detection. As a summary, we would like to address that the commercial business segment of the radiation detection globally, it is very fragmented, it is very diversified, but no operator can offer integrated A, B and C in the same package. And that's what we are focusing into it. And that's why we are asking, or we are applying for the richest business project having a duration of about 1 year or 1.5 years, because the ABC needs to be integrated into major and commercialization ready product. And that would require, in addition to already existing cutting edge detectors, for instance mechanical tooling, customer specific and user friendly operating and software electronics interface to be created. Okay, thank you very much, and in my backup slides we provide you the links for the additional very detailed technical information about our activities. Thank you.